Have you ever wondered if there's another version of you living in a different life in a parallel universe? Or if the mere act of watching this video can change the fate of the universe? Welcome to the mind-bending world of quantum mechanics, where reality is stranger than fiction. Picture this, a world where particles can exist in two places at once, where your choices create new realities, and where particles communicate instantly across vast distances. Ready to dive into the mysterious realm? Let's start with the basics of quantum mechanics. At the heart of quantum mechanics is the concept of superposition. Imagine an electron existing in multiple states or places simultaneously, only choosing one when we observe it. This is beautifully illustrated by the famous double-slit experiment. When electrons are fired at a barrier with two slits, they create an interference pattern on the other side, suggesting they go through both slits simultaneously. But if we observe which slit an electron goes through, it behaves like a particle, creating two distinct lines. Observation changes outcome. Isn't that mind-boggling? Let's take it a step further with entanglement. When particles become entangled, the state of one instantly influences the state of the other, no matter the distance between them. Einstein called this spooky action at a distance. This instantaneous connection suggests that information travels faster than light, defying classical physics. It's as if the particles share a deep invisible bond. Now let's journey into the concept of parallel universes. According to the many worlds interpretation, every quantum event spawns a new universe. In one universe, a particle goes through the left slit, while in another, it goes through the right. Every decision, every quantum event creates a branching point, leading to a multiverse of infinite possibilities. There could be countless versions of you, each living in a different life based on different choices and outcomes. Consider Schrodinger's cat, a thought experiment where a cat in a box is simultaneously alive and dead until observed. In the many worlds interpretation, when you open the box, the universe splits in one. The cat is alive, in another it's dead. This interpretation removes the need for a collapse of the wave function. Instead, all function outcomes happen, each in its own parallel universe. The journey of quantum mechanics began in the early 20th century. It all started with Max Planck, who proposed that energy is quantized, coming in discrete packets called quanta. This groundbreaking idea set the stage for a revolution in physics. Then came Albert Einstein, who explained the photoelectric effect using Planck's quanta, earning him a Nobel Prize. This was followed by Niels Bohr, who developed the Bohr model of the atom, introducing the idea of quantized orbits for electrons. Quantum mechanics truly took shape with Werner Heisenberg's matrix mechanics and Erwin Schrödinger's wave mechanics. Heisenberg's uncertainty principle and Schrödinger's wave equation became cornerstones of quantum theory. The debate between these giants of physics led to the intense discussions and new insights, ultimately unifying their theories into what we now know as quantum mechanics. The famous Copenhagen interpretation emerged, proposing that particles exist in all possible states until observed. Carl Sagan once said, "The universe is not only stranger than we imagine, it is stranger than we can imagine." Quantum mechanics continually proves this, stretching the boundaries of our understanding and imagination. Richard Feynman, one of the greatest physicists, famously remarked, "I think I can safely say that nobody understands quantum mechanics." This highlights the profound complexity and mystery that it still surrounds this field. Even Niels Bohr admitted, "If quantum mechanics hasn't profoundly shocked you, you haven't understood it yet." This insights from brilliant minds reminds us that humbling and awe-inspiring nature of quantum mechanics. So, what is this quantum mechanics in simple terms? At its core, quantum mechanics is the branch of physics that studies the behavior of particles at the smallest scales, atoms and subatomic particles. It reveals that these particles don't follow the predictable rules for classical physics, but instead exhibit strange and counterintuitive properties. To put it simply, quantum mechanics explains phenomena that classical physics cannot, such as why electrons can jump between energy levels in an atom, or how particles can be entangled across vast distances. It's the foundation for technologies like lasers, MRI scans, and quantum computers. There are four main types of quantum mechanics: non-relativistic quantum mechanics, quantum field theory, relativistic quantum mechanics, and quantum statistical mechanics. Each each type deals with different aspects and scales of quantum phenomena. Non-relativistic quantum mechanics, also known as Schrödinger mechanism, deals with particles at low speeds. Quantum field theory extends these principles to fields and particles at high energies. Relativistic quantum mechanics merges with quantum mechanics with Einstein's theory of relativity, while quantum statistical mechanics applies quantum principles to systems with many particles. Quantum mechanics isn't just a theoretical playground. It's paving the way for groundbreaking technologies. Imagine unhackable quantum communication networks, ultra-fast quantum computers solving problems in seconds that would take classical computers millennia, and even quantum sensors revolutionizing medical imaging and environmental monitoring. The future holds even more astonishing possibilities. Theoretical concepts like wormholes and space-time curvature suggest we might one day traverse vast distances instantaneously, much like a sci-fi anywhere door. Wormholes are theoretical passages through space-time, potentially connecting distant parts of the universe or even different universes. These concepts are rooted in the mathematics of general relativity and quantum mechanics, hinting at a future where our understanding of the universe could dramatically expand. To wrap it up, quantum mechanics is a fundamental theory in physics that describes nature at the smallest scales. It challenges our classical intuitions and opens up a universe of possibilities, from parallel universes to groundbreaking technologies. Embrace the wonder and mystery, for who we are just beginning to unlock the secrets of the quantum realm.